Okay, so now we're in the next section, 4.4. Now we're getting ready to go over constructors. Let's get into it. Okay, so 4.4 constructors. So let's get into the curriculum. 4.4 constructors. We'll often want to initialize or set the initial value of some of our fields when creating a new object from a class. Constructors allow us to do that. So in Java, constructors have the same name as the class and are most often declared public. Though they can have any other valid access modifier, they are declared without a return type. Any function that is named the same as the class and has no return type is a constructor. So here's our example. So now let's go back to our hello world. So here we go. We have our hello world. We have our private field object, high level object here. And so we want to create a constructor. So here, what I'm going to do is I'm going to make it public. Make my constructor public, and notice it has to have the same name as the class. And so I know it's a method because it has the parenthesis right here. And now I'm going to pass in the parameter message. And there I have my constructor. Now I'm gonna type this message because I want the top level object. And then I'm going to assign that message to it. So that's my syntax. So here I'm going to comment, this is a constructor. And what a constructor is named after the class with return type. Let me spell type right. There we go. So I gave myself a note so I can be able to identify what I'm looking at, right? So now that I identify that, so I can get into the habit of knowing the difference between constructor method, which is a special kind of method, versus just a getter and setter method or any other method. So I know that this is constructor method because it is named after the class. Now I say I have a related problem. Let's see what that is. Okay, so what it did was it connected me to my hello world. We'll look at that in a minute. Let's go down here. The constructor allows us to create hello world objects with custom messages. The assignment this.message assigned to message assigns the value passed into the constructor to the field message. Here's how we might use it. So we have the hello world goodbye, and then we print out goodbye dot get message prints goodbye world. Okay. So this is an instance that we are using in the hello but we're using to our hello world runner. So if I go over here to my hello world runner, and what I have here, let me go ahead and add this to it. Let's go ahead, see if it'll let me do it. All right, let me copy and paste that in. All right, and so let me see here. Am I got any errors here? Look like an error. Let me see here. Let me comment that out for a second. So I'm getting an error. Let me run this to see exactly what this error is, just so I can. All right. cannot find symbol, method get message. So it cannot find it because I haven't actually given it anything over here. Just let it know that I have a get message here. So I haven't declared it to find it inside my class. So what I'm going to do is let me comment that out for a second. Let me go back here because I think I have a message with this, an error with this as well, I think. Let me run. Okay, constructor hello world class. Let me read that. Constructor hello world in class hello world cannot be applied to a given type. Required Java lang string. Okay, what did I do wrong here? So let me go back up here. So I created and so here's some more information that I didn't add, right? So let me go ahead and get message. The reason why I can't get access to it because I don't have a getter and setter. So let me go ahead and copy these as well so I can have those in my code. So let me see, I have my getters and setters. There we go. I have a getter and setter, and I am going to comment all of this out for right now. All right, so let me see here. I still have a related problem, one related problem. So let me see here. Public hello string. I have my getters and setters. Did I do something wrong here? All right, so let me go back. Okay, say hello. Okay, not going to be able to work because that's not what I'm trying to get access to. So now let me comment this one out. I want to comment this one out and then I'm going to comment this one back in. All right, so see what's up. There we go. Missing return statement on student. Okay, let me go ahead. I don't need this one. Because it's going to give me that error because I'm not working with the student right now. So let me see if I can comment this out for a second. Boom. There we go. Now it's working. So if you run into these little problems, so it's always good for us to make mistakes so that we can walk through it because you may have the same challenge. So here we go. All right, so I'm back down here. It's not required that every class has a constructor. If you don't provide one, the Java compiler will generate an empty constructor for you, known as a default constructor. For example, when we left out a constructor in our Hello World class above, the compiler created the following constructor for us. So it was created for us by default, even though we didn't set one initially like we're doing now. It will set one for you by default because every class has to have a constructor, but that don't mean you have to declare one when you're writing your code because the compiler automatically gives you one until you specifically put one in. So while this can be convenient, you almost always want to provide a constructor to properly initialize your object. So it's best practice to always, let's go back to it, give yourself a constructor. And remember, the constructor is named after the class. It's always going to be the same name as the class. All right, so here, 4.1.1, overloading constructors. This is important. We can provide multiple constructors for a given class in order to allow for different initialization scenarios. This is known as constructor overloading. When providing multiple constructors, we must ensure that each has a different collection of arguments as determined by the number, ordered, or type of the constructor arguments. So let's expand upon our student class. So I'm going to go back over here to my student class. All right, so I open my student class back, uncomment stuff back in. So here we got the class student. And then we have all of our fields, our variables, our instant variables. And then we have our student constructor right here. So we don't have a constructor right here. We just have our getters and setters, right? So now if you notice here, I'm going to copy this. I'm going to omit, meaning I'm going to comment, which, if you hit this little minus button right here, I can just collapse everything, and then I can comment the whole thing out like that. So it's all commented out. So there we go. So that's been commented out, the whole thing. So now I want to add my constructors. All right. What do I know? How do I know this? So let me put my comments here. So I want to know that this is my constructor. So when I'm looking at this, I know what I'm looking at. And this is what we call constructor overloading. And so I'm going to go up here, put a comment up here. So I can know when I'm looking at this that, okay, this is an example of constructor overloading. So here I have two student constructors, because remember, constructors have to be named after the class. So they're still students. But now let's pay a close attention to the difference between the two. One is declaring, it has the properties of string name, int, student ID, int, number of credits, double GPA. And that I have inside of it, I have the object is referring to all of these instance variables, this dot name, this dot student ID, this dot number of credits, GPA. And then I'm passing inside of each one of these particular variables, I am passing in the value, which is the variable name as well. Now, if you see on the second one here, it says students. We pass in the name parameter and just the student ID. I don't have all four of them, but notice here as the parameter. But then notice down here, I do have all four of them, and I'm initializing two of them, which is the actual values that I actually want. So now let's read in the curriculum. The first constructor allows for the creation of student objects, where the code creating the object provides initial values for each of the fields. The second allows for the creation of student objects with only name and student ID. The first constructor will be most useful for creating a transfer student, where credits and a GPA might already be non-zero. However, for all new students, it will be safe to initialize number of credits and GPA to be 0. So what the constructor overloading is doing is giving us more options. It's allowing us to cover different use cases within our class. So a better way to write the above constructors would to be this is the better way to write it. As you can see here, as you can notice here, on my first constructor, I have the information, but my second constructor is a little bit different. What I did was I just created this. Let me go ahead and copy this so you can see it side by side. So when I come down here, as you can see, to look at that, we can compare the difference here. In this student constructor, I'm passing in this inside of a parenthesis. So it looks like a method, right? Because inside of the parentheses, I'm passing in name and student ID. And look how IntelliJ it does. It's number of credits, 0, GPA, 0. It's matching this right here. So if I comment that out, it's giving you some highlights right here. It's just, this is how smart IntelliJ is. It's letting you know that name, student, and when I put that 0 in there, it gives me the number of credits, GPA, because it's matching right here, this particular, these values right here. It's matching these values right here, these instance variables. So when I did it, name, student ID, and then I added 0 and 0, it automatically understood that I want these particular instant variables right here. Very smart. Now, in the example above on line 17, we used this in parentheses to invoke another constructor within the same class. In this case, the second constructor calls the first with the default values for number of credits and GPA. If you use this syntax, the call to this must be the first line in the constructor. This is a good practice, not only because it makes your code shorter, but also because it allows any initialization behavior that may be carried out beyond just initializing variables to be contained in a smaller number of constructors. In other words, constructors can share initialization code. Notice from this example that a constructor does not need to require an initial value for each field as an argument. When defining constructors, think about 1. Which fields must be initialized for your class to work properly? Be sure you initialize every such field. 2. Which fields should be initialized by the user creating an object, and which should be initialized by the class itself? What are the use cases for your class that you should provide for? Check your understanding. Now we made it to the end of this particular section. Again, go ahead and finish the rest of this chapter out and then come back to this and take your time to understand it. Give yourself some time to understand it. Then when you begin to work on the exercise, you know where the information is, so it'll be easier for you to go back and find it. So remember, the more you practice, the more you improve. See you in the next video.